Hey guys, my name is Nitish, and I'm honored to be one of your teachers on your journey to become a calc beast. In this video, I'm going to be explaining different questions and average rate of change. I'll explain the concept and move on to some practice problems afterwards. In this video, we're going to be looking at one of the first equations used to calculate the derivative of an equation. So jumping right into it, derivative of a function of a real variable measures the sensitivity to a change of function value, output value, with respect to a change in its argument, which is the input value. So basically, derivative is just the graph of the slope of every point on a graph. Trying to visualize it, imagine a tangent line at every point on a graph. And graphing all those slopes will get you your derivative graph. A real life example. Let's say you traveled 30 miles per hour in your car for 5 hours from your house. Let's graph this. This graph would be linear, right? If we try to take the slope, this is 30, this is 1, and 30 over 1 is 30 miles per hour, right? So now how do you think the derivative of this graph would look like? The derivative is the speed or velocity of your car, right? So at 0, 0, what's the speed? The speed is going to be 30, right? Because if we look at 0 to 1, this is 30 and this is 1. That's 30 miles per hour. So at 0, it's going to be 30. Right, let's look at 1. 30 to 1. Right, so that's 30 miles per hour. And we see that 31 pattern. We know the speed is constant, right? So the speed stays constant at 30, and the graph would look like a straight line from 0, 30, the coordinate, 0, 30, to 5 is the hours, 5 to 30. Now that's the derivative of this graph. Right? So if we were to look at it like the slope, at x equals 0, the slope is 30. Yes, the slope is 30. Right? So derivative says the slope of the inertial graph at every point in time. If we looked at 30 minutes right here, minutes, right? The slope is 30. Here, this is 30 minutes, right? Right. What is from here to here? This is 30 and this is 1. That's 30 miles per hour, right? You just did your first derivative. Poggers. Now, let's look at this in a more calculated way. Let's try to create an equation from this, what we learned so far. This is the graph of x squared. Let's try to find the slope at x equals 1. Tangent, we want to find the slope of this. Right. First, let's try approximating the slope. Let's take 2 points, 2, 4, and then 1, 1. And use our equation. y2 minus y1 equals x2 minus x1. We find that the slope of this line right, slope of that line is 3, right? Now let's look at the difference between the approximation and the tangent line, right? For the approximation line, the width between x1 and x2 is, that's 1, right? Let's say that variable is h, right? The width is 1. What's the width for the tangent line? Tangent line, the width is 0, right? So what we want to do is we want to utilize this thing called limits in calculus, and we want to try to get the width from 1 to 0, right? Limits are, let's say, limit of a approaches 0 for f of a, right? And the graph of f of x looks like this, right? Graph of 1 over x. When we say a approaches 0, we're saying as the x value approaches 0, and what's the y value there? For this graph, this would equal infinity, right? Let's try to use f of x in limits. Let's try to convert these four variables into f of x, right? So what's x1, right? If we're using the variables x, h, and f of x, right? x1 is just x, right? Here x1 is just x. x2, that's x plus h, right? And y1, that's f of just x, there's no h added on to it. y2 is f of x plus h. And let's just replace all the variables there. So limits of h as I approaches 0, because we want the width from 1 to go to 0, right? And f of x plus h minus f of x over, what's x2? x2 is x plus h, then minus x1, which is x. And we cancel the like terms, which is the x and the negative h, or negative x. These two cancel, and then h. And that is our first derivative equation. Now let's try to find the slope of the tangent line at x equals 1. What's f of x? f of x equals x squared. Right, let's just keep that in the back of my mind. Limit h approaches 0, f of x plus h minus f of x over h. Now we can't say h equals 0, because if we did that, our denominator would equal 0, and we can't have that, right? So h does not equal 0. Limit h approaches 0. And f of x is just x squared, right? So we can say x plus h squared minus x squared over h. And we know x equals 1, right? That's what we're solving for. So, limit and let's simplify this. H. And that should be, the ones cancel out, right? So h plus 2. And since h is approaching 0, it should hold it should be so close to 0 that we can just say it's 0 at the end, right? So this should equal basically 2. And that is the slope of our tangent line at x equals 1. Yeah. Now let's look at some practice problems, right? So f of x, right? Let's use our equation. Limit of h approaches 0 of x plus h minus f of x over x plus h minus x. X cancel out. Limit of h approaches 0. 3 of x plus h. We're just substituting the x plus h for the x value, right? Minus 7 minus 3x minus 7 over h. 3x plus 3h. And the minus, this becomes a positive 7, this becomes a negative 3x. Right, these 7's cancel. And minus 3x. These 3x's cancel. And this h becomes 1. And 3. Right? That just becomes 3. Right? So 3 will be our answer. Let's go on to the next problem. our equation, h approaches 0, x over h. Of 7 minus 2 x plus h minus 7 minus 2x, and then the whole thing in parentheses over h. Now let's distribute the negative, right? That'd be negative 7 and then positive 2x. Limit of h approaches 0, 7 minus 2x minus 2h plus negative 7. And then plus 2x. The 2x's become 0, 7's become 0. And the h becomes 1, h's. And that equals negative 2. That is our answer for this problem. Next question. Alright. Limit of h approaches 0, f of... Now this one's a new one, x squared, right? Let's try to continue with the equation that we have, right? X plus h minus f of x over h. It's x plus h squared, because x plus h is just x. You substitute it for x, right? And then, oh, we forgot the plus 7. Plus 7 minus x squared plus 7. Right, let's distribute the negative. So negative x squared, and then negative 7. All that over h. Limit h approaches 0. X squared plus h squared plus 2 xh using the FOIL method. And then that's negative x squared minus 7. The 7's become 0, x squared's become 0 over h. Limit of h approaches 0. And the h becomes 1. Right. So that's h plus 2x. Now here we're left with an h, right? Now remember at the end I said h is just basically 0. It doesn't have a real volume. So we can just say that's 0, right? So we can just say that equals 2x. Yay. Alright, let's move on to the last practice problem. Limit h approaches 0 to, for f of x plus h minus f of x over h. Limit of h approaches 0, and then 2 x plus h squared minus, that's plus, right, 6 x plus h, and then minus 5 minus 2x squared, and that's all in parentheses, plus 6x minus 5. Let's just distribute the negative, right? Negative 2x squared, and that's a negative 6x plus 5 over all that over h. Limit of h approaches 0, 2x squared plus 2h squared plus 4xh. I'm just distributing everything here. Plus 6x, and then plus 6h minus 5, and then minus 2x squared minus 6x plus 5 over h. That's a big line. Limit h approaches 0. The 2x squareds become 0. The 6x's become 0. The 5's become 0. We're left with the 2h squared, 4xh, h. Yep. And then let's take out the h's here. Right? 2h squared plus 4xh plus 6h for h. Okay, so since this is squared, take out the squared, and then this h becomes 1, this h becomes 1. We're left with 2h plus 4x plus 6. And h is approaching 0, so that's 0. That equals 4x plus 6. Nice. Alright, that's it. I hope that helps. This subject is called Different Quotient and Average Rate of Change. You can do this. Right. If you have any questions, you can leave them in the comments, and I'll be sure to answer them. Yep.